An ant can lift 50 times its own weight, a tiny creature with unbelievable power. But if that ant suddenly became the size of a human, could it lift a bus or would something unexpected happen? To know the answer, we first need to understand how strength changes when we scale something up. When an animal gets bigger, its weight grows faster than its strength. That's because strength depends on the size of its muscle. Maximum weight ant can lift is equal to muscle tensile strength multiplied by cross section area of ant's legs. Here, muscle tensile strength is constant. Area grows with the square of the scale factor k. So, muscle force also grows with the square of k. Weight depends on volume and volume grows with the cube of the scale factor k. So, weight also grows with the cube of k. This is called the square cube law. So, strength to weight ratio is proportional to k squared over k cubed or 1 over k. Here, strength means the maximum weight an animal can lift. That means strength to weight ratio is inversely proportional to the scale factor. When an animal's size increases, its ability to lift weight decreases. If the animal was originally able to lift n times its own weight, then after increasing its size by a scale factor k, it can lift only n divided by k times its own weight. So, no matter how strong a creature is at its normal size, scaling it up too much will always make it weaker relative to its own weight. A typical ant is about 5 millimeters long and can lift 50 times its own weight. What happens if we scale it up to the size of a human and say 1.7 meters tall? First, we find the scale factor. K is equal to new size divided by original size is equal to 1.7 meter divided by 0.005 meter is equal to 340. Before scaling up, the strength to weight ratio of our ant was 50, meaning it could lift 50 times its own body weight. But when we scale it up to a human size, that ratio doesn't stay the same. Because strength to weight ratio is inversely proportional to the scale factor, it drops dramatically. In our case, the scale factor is about 340, so the ratio falls by a factor of 340. That means our giant ant's new strength to weight ratio is 50 divided by 340. Strength to weight ratio is approximately 0.15. It could only lift about 15% of its own body weight. Not enough to lift a truck, in fact, not even enough to hold itself up. Our human sized ant might collapse under its own weight before it ever picks anything up. In the miniature world, strength rules, but in the giant's world, weight always wins. That's the beauty and the curse of square cube law.